Have you ever been in a taxi watching the meter only to have it jump at the end of the ride? Most taxis charge for each mile or increment of a mile, so the price goes up at the end, even if you've only driven a small portion of a mile. For example, consider a taxi that charges a flat rate of $3 plus $1 per mile, or any increment of a mile. The cost is a function of the distance driven, X miles, and is defined in increments or intervals. We see that if our taxi ride was 2.35 miles, for example, we would get charged $6, even though we didn't go the full 3 miles. When a function is defined in pieces, as this one is, we call it a piecewise function, and we represent it using notation that gives an output for each interval of inputs. Our taxi function is a special kind of piecewise function called a step function. A step function is a function that increases or decreases in steps from one constant value to the next. Within the step function family, there are floor functions and ceiling functions. A floor function is a step function that includes the lower endpoint of each input interval, but not the higher endpoint. A ceiling function is a step function that includes the higher endpoint of each input interval, but not the lower endpoint. Since our taxi function includes the higher endpoint of each input interval, but not the lower, it is a ceiling function. There is a very valid reason for the name of a step function. To observe this reason, let's graph our taxi function. Wait, how do we do that? Let's figure it out. Graphing a step function is the same as graphing any piecewise function. We simply graph each part of it separately. When dealing with a step function, this results in these steps to graph the function. 1. Draw a horizontal line segment at each constant output value over the interval of input values that it corresponds to. 2. Draw a closed circle point, a filled-in circle, at the included endpoint on each horizontal line. 3. Draw an open circle point, a circle not filled in, at the endpoint that is not included on each horizontal line. Well, that doesn't seem so hard. Let's graph our taxi function. First, we draw our horizontal line segments at each cost for the interval of miles that it corresponds to. Next, we'll draw in our included endpoints with a closed circle. Lastly, we draw in the endpoints that are not included using an open circle. Wow, that really was quite easy. And now we have a graph of the step function representing our taxi's fee structure. Do you see why step functions have their name? The graph looks exactly like a series of steps. Pretty neat. Let's look at one more example. Suppose you just bought a jet ski for the price of $3,500. You bought it using credit, so you decide to rent out the jet ski to make money to pay it off. You decide to be nice and charge $50 an hour in such a way that the cost jumps up by $50 once you hit the next hour, rather than having it jump up as soon as it hits an increment of an hour. This allows for your customers to get their first hour for free, a great incentive to rent from you. If the customer rents the jet ski for X hours, the fee structure is as follows. We see that your fee structure results in a step function that includes the lower endpoints, so it is a floor function. You decide to make a sign with your fee structure on it, and you want to include a graph of the fee function. To do this, we need to graph the function, so let's get to it. First, we draw horizontal line segments at each cost along the interval of hours that it corresponds to. Next, we draw in our included endpoints with a closed circle. And lastly, we draw in the endpoints that are not included with an open circle. Ta-da! We have our graph. You can now make your sign and have your jet ski paid off in no time.